Alrighty, so let's take it up a notch. We're going to be dealing with zirconium, and you should be able to, from the periodic table, see that zirconium is atomic number 40, so if it's neutral, and it is, we're finding homes for 40 electrons. So we've got our arrow diagram over there in the upper right-hand corner, and we're going to write the electron configuration in spectroscopic notation, again using what we call the order of filling, which is just what we've done using the arrow diagram, order of filling. So here we go. First two electrons, where do they go? In the 1s, so 1s2. The next two electrons go in the 2s. Now which subshell are we ready for? We're ready for the 2p, and we can put 6 electrons in there, so 2p6. Now anytime you kind of are doing a spectroscopic notation or box and arrow notation, and you end up with kind of having completely filled with 6 electrons, a p-type subshell, you are bumping up against the end of the period. You're bumping up against a rare gas. So this actually is neon. All right? So we're up to 10 electrons on our way to 40. Where do the next 2 electrons go? In the 3s, 3s2. What subshell do the next electrons go in? They go in the 3p with 6 electrons. Perfect. And again, so we are bumping up against the end of the period. This is actually argon. And when we what did we do? Potassium a little bit ago, we actually had to do the same configuration to this point. All right, so where do the next electrons go? In the 4s, so 4s2. So now we're up to 20 electrons, which is beyond what we were before. So now where do the next electrons go? The next electrons go in the top of the next arrow, which is 3d. And we need to completely fill that, because with, let's see, 18 plus 2 plus 10, that's 30? So that's only 30 electrons, so we've got to totally fill that. Are you guys good with this whole thing, that in all of these Ds we max out at 10 electrons. In all these Ps we max out at 6. In all of these S's we max out at 2 electrons. How many do we max out at the F-type? 14 electrons. Okay, all right. So, clear the screen. So where do the next electrons go? They go in the 4p. And it looks like we're going to have to completely fill that one too. So it's 4p6. So we're bumped up against what? Another rare gas? We are at krypton. Dun, 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 dun. So we need to slow her down a little bit. We're at 36 electrons on our way to 40. Where do the next electrons go? They go in the 5s, and we'll completely fill it with 2 electrons. We've got 38. Very good. Where do the next electrons go? They go at the top of the next diagonal, so they go to this guy right here. And we only need, what, 2 more? So it's going to be 4d2. Yeah, not bad. Okay? So a few things, I'm going to use this as an example to point out a few things. First off, I'm going to go to the next slide. Okay, what you had on the previous slide was this. This is what we call the order of filling. This kind of comes as a natural outcome of using the arrow diagram. It's great. I'm telling you, it's great. But sometimes you want to actually unscramble all of those 40 electrons, unscramble them according to their N. So do you see, for instance, where here we have 3, 3, 4, 3, 4, 5, 4. So increasing N, basically, however you want to look at it, it moves this 3 over, so the 4's can be together, and the 4 over, so the 4's can be together. So increasing N, same electron configuration, it looks like this. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d2, 5s2. The reason you'd ever want to do this, and sometimes students say, do I need to do this? No, you don't have to if you're coming up with electron configuration. But do you remember, well, maybe, I guess it's coming up. I think I maybe talked about it. Valence electrons. I think I mentioned it already. But valence electrons is are electrons in the highest N. Okay? And N, I mean the highest N. So here this is N of 4 and this is N of 5. So actually we have 2 valence electrons and there they are in the 5s. Okay, so that's kind of nice, kind of reordering your subshells like that. The last thing I want to mention is this, you're going to like this I think, the abbreviated rare gas notation. Oops. Don't I do that here? Oh, I guess it's on the next one.